Using trig identities, oh boy. We have all those new friends to learn. Reciprocal identities, cofunction identities, even odd identities, quotient identities, Pythagorean identities. We've got all those good friends. 23 new friends, in fact. Use your new 23 identities to solve this problem. Let theta be in quadrant 2. Well, you know what? I know something about quadrant 2. I know ASTC. In quadrant 2, the sign is positive. Oh, am I surprised at all that sine of an angle is the ratio and the ratio is positive in quadrant 2? Find cosine. How can I link sine and cosine? Oh yeah, I remember. Sine squared theta plus cosine squared theta equals 1. And remember, we write it like that, but it really means this, right? The whole thing squared. So this is 1/3 squared plus cosine squared theta equals 1, which means 1/9 plus cosine squared theta equals 1. That's 1/3 times 1/3 gives us 1/9. If I subtract 1/9 from both sides, look what I do here. I'll turn 1 into 9/9 to give me cosine squared theta is equal to 9 minus 1 is 8/9. And that means cosine theta, what they asked us for, is plus or minus the square root of 8/9. Now I have to remember the square root of a over b can be written as the square root of a over the square root of b, an important idea from algebra. So this is, by the way, if we're talking about a quadrant 2 angle, I have to go left and up. Of course, the sign of cosine, the plus or minus sign, is negative. So I don't have to be Mickey Mousing around here saying plus or minus, plus or minus. I know that the answer here will be negative. And this will be the square root of 8 over the square root of 9 with a negative out in front. Well, that is the square root of 4 times the square root of 2 over square root of 9 is negative 3. So this will give us negative 2 square roots of 2 over 3. And that is our answer. And we found that just using identities. I solved this problem just using identities. Aren't those identities amazing? I think I got it right. Let me just make sure. If I draw a quadrant 2 angle here, theta is a quadrant 2 angle, and I know that the sine, look what they've told us, the sine is opposite over hypotenuse. This is 1 and 3. If I'm looking through our theta prime, right? Oh, it's not a unit circle. Does that bother anyone? We could have made it a unit circle. Sorry, there's theta prime. And I don't know what this side, I'll call that x, is. Well, I know that x squared plus 1 squared equals 3 squared. So x squared equals, if I subtract 1 from both sides, that's 9 minus 1 is 8. And x is plus or minus the square root of 8. But because we're going to the left, I'm not going to Mickey Mouse around. I know that that is negative. So this is x is negative root 4 times root 2. So x is negative 2 root 2. This is my triangle, negative 2 root 2. So they asked us for the cosine of this angle, as we look through, is adjacent, negative 2 root 2 over hypotenuse. Notice, for cosine, adjacent over hypotenuse always works. I've stressed this many times. When do I say cosine is the x? Only when we're talking about a unit circle. But if I made this 3, we're not talking about a unit circle. But what if you said, I want to make this a unit circle? Not a big deal. Same answer will be procured. Here's our theta. And if you say, I want this a unit circle, well then sine is the y. And now we're saying x squared plus 1/3 squared equals 1 when I do leg squared plus leg squared equals hypotenuse squared. So this will give us x squared plus 1/9 equals 9/9. So x squared equals, if I subtract 1/9 from both sides, 8/9. And that would imply that x is equal to plus or minus the square root of 8/9, which you saw simplified to root 2 over 2 over 3. And because we're negative this way, I'm going, to the left on the x-axis, I'm going to put negative. So you could use this picture as well. Depends on what you prefer.